Thank you. So, fail fast, move forward. And now incidents are new normal. They are part of the development process. And out of that, we come prepared. We are seeing more and more software released to Canary first. Feature flag adoption is growing. And observability are our eyes and ears into turbulent reality of production. And industry leaders are showing us how to shorten loop from production, how to set up proper alerting. We know that things are going to fail. The only question is when. We will get notification about critical incident on a really important date. It will happen in the middle of night. So I took this picture when my partner had 24 hours on call. And as long as it happens rarely, it is okay. But fixing and seeing another similar popping up a few days later, is game worth playing? I don't think so. So should we give up the idea of fail fast, move forward, and move back to enterprise waterfall? Don't think so. So I'm gonna show you how you can actually benefit from your incidents and learn more about your product, about your users, and about your organization. So my name is Kasia. I work at Dynatrace, and I'm really experienced in making mistakes or incidents. But I'm also an experienced incident facilitator. And in this presentation, I will show you how you can facilitate a post-incident review. Why you should be interested in organizing incident review? Why it is valuable? Because software engineering isn't simple. Sometimes as engineers, we don't address the substance of the problem, either because it's too difficult, it requires us to get out of our comfort zone. And for example, we need to make change in the process. Or sometimes it's just easier to implement smaller fixes. Likely, they won't address the main problem at all, but at least the implementation was easier. So before we start analyzing incident, we need to remind ourselves that we are flawed and software is bustling with life. And as engineers, we are just a small part of a complex system. Often, the way our services, subsystems, or departments in our organization are interlinked with each other is really hard to comprehend. And remember, one of the beautiful things about complexity is that we couldn't design it, even if we wanted to. If something so complex could be designed, it wouldn't be complex. It would all have to fit inside of the head or maybe computer model of a designer or design team. Complexity is not designed. Complexity happens, and complexity grows, and it grows on itself. It typically grows more on itself. So check your humility before you start analyzing the system. Single root cause of an incident doesn't exist. System can be made of many parts that in isolation work perfectly. Still, an incident could happen as a result of weird interactions between the working parts, either software or people, or both. We make our system relatively safe from single point of failure, but often serious incidents resemble a perfect storm where many bad events happen at the same time, making the whole situation even worse. So if we want to build a viable product, we need to care about culture first. And there are four main elements of reliability culture. Leadership is the first one. So without commitment from our leadership, there is really little point in trying to promote the culture of reliability. If your leaders decide that developing new features is most important, then they will likely not support initiatives focused on reliability. They will push into different directions. They will not approve investments in improving how organization works. And reliability isn't something that a single developer can solve during hackathon. Reliability isn't built by running house engineering from time to time. And responsibilities of a team leader include limiting work in progress and eliminating roadblocks for the team so they can get their work done without pressure. Reliability is not property of organization, but is capability. It's like with lean. So you cannot say that your organization is reliable by inspecting how it does at a given time. You need to observe it over a period of time. And the need of redundancy is the second element. And the idea behind redundancy is that it is the only way to build reliable system out of unreliable parts. And multiple and independent channels of communication and double checks should, at least in theory, be able to produce a highly reliable organizations. And redundancy in high reliability theory can take two forms: duplication and overlap. In duplication, we have two different units or people or services perform the same function, often in real time. And overlap is redundancy where units or people or paths have some functional areas in common, but not all. So, for example, we can have developers with SRE backgrounds to reduce time to react to incident. Decentralization and agility form that here. And high reliable organization delegate and foster autonomy. Team members must be given authority to make decisions that affects their work and their jobs, especially in areas where they are responsible for the outcomes. So people have saying in the way they work and evolve their practices. And as a result, when incident happens, they don't wait for someone else to take over. They alone can assess severity and suggest remedy. And organization learning is the fourth ingredient for high reliable organizations. And high reliability grows out of incremental learning through experiments and errors. Things are attempted, new procedures and solutions are tested, and the effects are measured. Smaller dangers are courted in order to understand and foster larger ones. Simulation and imagination, for example, disaster exercise, house bashes, are really important ways of doing so when the cost of failure in real systems are too high. And for high reliability theory, such learning does not need to be centrally orchestrated. The initiatives can be made by, and decision can be made by developers team. So after fire is gone and we fix our incident on our production, we can organize incident review. And some organizations use term postmortem, and I will stick to incident review because postmortem means occurring after death. So it doesn't fit to our system and to software engineering because in majority of cases, our business or product will survive the incident and it will be still alive. So I really believe that we should normalize learning from incidents. So if we have code review, design review, KPI review, performance review, so we can have also incident review. And the first important step to organize the incident review is to invite or to become a facilitator. And facilitator from outside of the team brings a really fresh perspective. This perspective is important because during incident, people do what makes sense to them at the time of incident, given their experience and familiarity with process, or sometimes with tools, and also their understanding of the current situation. So facilitator who doesn't know what are the norms and procedures helps to discover and understand how team perceive the world at the time of incident. So when team is responsible for analyzing incident, they often too focused on the incident itself. They talk about insufficient testing as the thing responsible for failure, or not enough detailed monitoring. And team is so often so focused on the incident itself that they miss the whole context. So facilitator helps to uncover it by asking open-ended questions, getting oral description from all involved. And those details often are in the form of some tactic knowledge, and facilitator helps to surface. Facilitator also helps people open up and get out of apathy caused by recurring failures and failed attempts in preventing them. And as facilitator, you need to remember about two most common biases. The first one is hindsight bias, also known as knew it all along effect. And hindsight bias refers to our tendency to overestimate in hindsight what one has known in the foresight. In other words, it is those aha, I knew it moments you have on your daily basis, which were just lucky strikes and you wouldn't have guessed at all. So in incident review meeting, you can often find people who don't believe that analyzing incident brings value, because that was obvious that this service, this feature was gonna fail. And we should blame people who made this decision. So we have tendency to overestimate in hindsight what one has known in the foresight. The other important bias is availability bias. And as humans, when we make a decision, we have tendency to use information that comes to mind quickly and easy. So if you invite only developers to incident review, you will look at the problem from single perspective, developers. So they will focus on elements which are more familiar to them. So like software, infrastructure, code. If you want to be a successful facilitator, the first step to take is to familiarize yourself with all perspectives. And as facilitator, it is important to invite people other than software engineers. Invite people who discovered issue, investigated issue, fixed the problem, communicated issue externally, or other interested. Like sometimes people from marketing, or if you are trying to analyze really complex event, it's good to take a note keeper or note taker. Sorry. And you care about all these people because each perspective is unique and important, and you are in the pursuit of objective truth. And we are not looking to merge those multiple perspectives into a single story. Quite opposite. The value is in the multiple narratives. So you look for contrast and things that complement each other. Another reason you want to get as diverse crowd as possible is that each person is an expert in specific domain. So once you start digging and asking people about their daily basis practice, you will hear about the habits that they developed over time, about shortcuts, about checklists that they use, or sometimes about the secret scripts. So you will hear about procedures they follow, or sometimes they don't. So And we look for broad, systematic improvements. We are not interested only in how developers work. And the hardest problem in tech is that you have to talk to people, and incident review need to be blameless. So assume that every team and each member act with best intentions based on the information that they had at the time. Instead of identifying whoever screw up, focus on finding gaps in process and correct them. So play the ball, not the player. Tell up front the reason why we have incident isn't to point fingers. Remind everyone that we are having incidents because we are successful. We have software that is running on production. We have paying customers and real users. So the reality is that sooner or later, we are gonna have incidents, and we cannot avoid to that. So we need to be prepared. And failure is inevitable. Success is really elusive. And success isn't the absence of failure. It is the ability to cope with the things that are changing continuously. And in an incident review meeting, we don't talk only about why things went wrong, but also how did things go right. So as facilitator, you don't want to look like you are FBI agent because it isn't interrogation. The most important tool in our arsenal is empathy. So incidents are stressful enough. People actions they took were the best in the context they had. And this is called local rationality. So no one wakes up in the morning thinking their change is going to cause an incident that will impact 80% of customers, that they will take down production, and Martin will have to fix it at 3 a.m. So everyone wants to perform a good job, be the best engineer. So when emotions run high and people start to talk about actions using words like, if they only had, they could have, they failed, they should know, make a pause in the discussion, change topic, tell, for example, a joke about your biggest failure. Empathy can be a really powerful tool. Say, we are in this together and we can learn from this. We don't want to discourage engineers from changing something in the core element of our system. We want to empower them to take this risk. So once we gather individuals, we can start drafting a timeline of the incident. And we want to build a context of the incident by connecting all the perspectives and gather all facts, all events, and everything else related to the incident, and identify cause and effect relationship and arrange them chronologically. So if you work on small project, then just grab post-its and markers, or use virtual boards like Miro, and together with your team note down all the events. But if you work on a complex project, use a tool which generates a timeline from infrastructure perspective. So you can use, for example, Dynatrace, and it's good practice to use this infrastructure perspective and later add human layer with stick notes that you are putting into the infrastructure. The timeline is our foundation of the review because it helps to build a common understanding of what had happened during the incident. And it's not description of a bug or fault. It's a good idea to use additional data that may help construct timeline, like chat transcriptions, logs, or dashboards that people observe during incident. Timeline is on our organization and how it behaves before, during, and after incident. Timeline also helps to look at the incident from higher perspective, to understand the perspective of people outside our tribe. And the important fact is that timeline doesn't need to be linear. So when we have a recurring event, it might be hard to represent it by a single connection. For example, one of the events that led to the Challenger and Discovery disaster was the fact that they've been using bullet points in reports. So these have been the result of local rationality trade-offs to increase efficiency in communication. Palletized presentation collapse and conclusion, and it's more difficult to analyze them and find problems in them. So sometimes one timeline also may not be enough. For complex events where we have more than one department is involved, and there are a lot of dependencies, for example, with third parties or other companies, you can ask each part to create its own view of what happened in the chronological order. And discussion over the timeline are a great opportunity to discover stories behind the incident. So the questions you ask are the key to encouraging discussions and making people feel more comfortable. Some groups won't need to start conversations. Other groups will wait for direction from the facilitator. So it's really good practice to have questions prepared in advance that may help start the incident review, even if you don't end up needing them. And the best facilitators encourage conversation through open-ended questions. So don't ask about when did you discover that service is down. Instead of this, ask about how did you notice that something is broken. And when you are facilitating, it is really important to look for descriptions, not explanations, because sometimes people are afraid to tell what had happened, and they are trying to answer in really use and really defensive way. So it is important to couch those mysterious answers and try to dig a bit more. So, for example, if someone says, "Oh, it seemed a little off," you can ask about details. So, what specifically made you think that it seemed a bit off? Things that led, but we also want to understand how things are usually going. So most of the times our system works fine and we are prepared to fail. We use canary releases, feature flags. We test our solution before pushing into production. And I really love this meme that was created after YouTube was down last year. And it's a show that we are ready to fail. And it is important to talk and share what we are doing to make our system bulletproof. And we want to share all those innovations and good practices beyond our team or even beyond our product. So when timeline is done, we can start looking for causal factors. And causal factors are events or actions or sometimes lack thereof, which led to incident or worsened its effect. Causal factors are mistakes in the process that led to the incident. They are either always or transistently present, and incident is just the first point in the time where causal factors are combined into a perfect storm. Causal factors alone, they don't cause big incidents. So not enough time for testing, not enough detailed monitoring. Those are examples of common causal factors. And suggesting that those are key to understanding incident is just misleading. We need to go deeper and find root causes. Root causes are everything that allowed the mistake to happen and to be ignored. And the easiest way to find roots is to start with causal factors and go deeper with 5 whys or 5 hows technique. So let's imagine that engineers detect some problem. They perform rollback to the previous version, and the rollback they didn't help, and they ended breaking stuff even more. So when you, as facilitator, you ask them why they tried the rollback, they will tell you the story behind the procedure in a case where the whole production is down. They will describe sources of pressure or how they coordinated on call. So we, as facilitator, we can gather information about how this actually happened and what conditions allow to it. So, for example, we had incident where a locked database hanged a service. And we used this technique and asked question about why database was locked. Because database was under heavy write load. Why database was under heavy write load? Because nothing cut the extra load. Why nothing cut the extra load? Because we didn't expect the database to ever be compromised. And why we didn't expect the database can be compromised? Because we never done any stress test to find the limits. And why we didn't test it? Because our process doesn't require service owners to think about capacity and fallback. So there are also few myths about 5 whys. One is that 5 is too many or too few. And there isn't any rule that 5 whys isn't mean to be literally 5 whys. So sometimes you will get answer with 3 whys, sometimes with 6. And the point here is to keep going and take a deeper analysis of your cause and effect chain. Also, there is rarely a single root cause. And yeah, that's true. There is no hard and fast route to your final why has to be a single cause. The goal here is to use a simple question, why, to get to the heart of what went wrong. And more complex problem might require additional approaches, but that doesn't negate the power of simple strings of whys. And the most important myth is that 5 whys contributes to blame culture. And one of the foundation's rules for 5 whys is never to identify a person or people as the root cause. So human errors, lack of employees, X attention aren't acceptable answers to the question, what caused the human error? But I really understand that sometimes why really contributes to blame character, and it depends from company. So if you feel that why doesn't work for you, try to use how instead of it, and it should be better. Successfully minimizing consequences. So we don't increase our success by trying to prevent things from going wrong. We do it by making sure that things go right. And quality and reliability are business concerns. So each time when we face the incident, we need to assess the risk and make decision. Can we handle the same incident twice? So when we discover a weak point in our process, we can think about how we can address it in the future and ask questions. What can we do to reduce the time it takes to identify similar problem in the future? What can we do to reduce the time it takes to resolve similar problems in the future? Or what can we do to reduce the number of users affected by similar problems in the future? Or last but not least, what can we do to eliminate similar problems from ever recurring? And we can define 2 types of action. First are corrective actions, where we know that problem may appear in the future. So we need to think about how we can improve detection, or reduce the chance of occurring problem. We can do this by improving monitoring, improving our test strategy, or similar. The second type are preventive actions, and their goal is to eliminate the cause of the potential incidents at all. So good action should meet requirements like proper action should be possible to finish at the assumed time. For example, team came up with idea that we should totally change our architecture, that microservices, like they don't work for us. So is it good preventive action? No, that's our wish. It's not possible to finish this in 6 or 3 months. So also, the decision about what we want to do must be our agreement. So we need to get acceptance from our change founder. If we don't get approval from our team or business, then we can have problem with realization of our change and with adding our actions to our roadmap. And finally, we should define who is the owner of action and who will be responsible for driving the change. And it is important to remember that implementing action doesn't give us a warranty that our software won't fail in the future. It is important to monitor actions and check does they work or what impact they have on the development process. Because fixing properties of a system that brought this failure into being may actually impact somewhere else at some other time. So this is a feature of complexity. Changing something in one corner can lead to vulnerabilities elsewhere. And this happens because making changes to some components in a complex system affects other components. And the power of complexity is that we can be surprised how our software was impacted by really, really small improvement. So once we had incident resulting from not following migration process. So we decided that we will release all changes behind feature flag. And this solution worked till the feature service went down, and we started to use caches, which weren't available on Construct, so we couldn't scale up. This is one feature that make complex system complex. The boundaries are really fuzzy, so it is almost impossible to say where the system begins or ends and which part can be affected. For our previous example, with that our process doesn't require service owners to think about capacity and fallback, we can define preventive generate synthetic load on our staging or dogfooding environment, or we can any given time. Or we can configure monitoring for existing infrastructure.
You there, Kasia? We lost you for a second.
Yeah. Yeah, I lost you too, so yeah. But now it should be fine.
Looks like you're back.
Yeah. Okay, so defining actions are really optional. And in the past, I really believed that incident reviews should finish with defining preventive actions and corrective actions, and that will prevent the occurrence of incidents in the future. But the sad reality is that sometimes it's better to decide that we don't want to implement any action than declare actions and ignore them. But there is one mandatory actions Share your learnings. So if you learn something new from incident, share it. Create a Jira issue with description. Write a blog post. Organize brown bag session. Or just write on Slack or just tell someone. Because if you think that something is obvious to everyone, it's not. And teaching is an incredible way of ensuring that you really understand what is happening in your system or in your organization or in your product. Building a learning organization is a real way to be proactive. That's how you actually prevent incidents. And your systems are failing. And anyone who says that failure is not an option, either ignorant of complexity. Failure is an option because we don't get to choose to fail. It is going to happen. And if we are trying to prevent all failures, and a lot of knowledge of your system comes from failure. And as said by Winston Churchill, never waste a good crisis. Never waste a good incident to improve your organization, team, or product. And we need reliability, and we must adapt our system to changes. Learning from gaps highlighted by incidents can guide the direction in which systems should evolve. And incidents are a new normal, but it doesn't mean that having constantly broken production is normal. We should build our software quality and reliability in mind, and in modern products where things are changing rapidly, failure is inevitable. We strive to reduce the number of incidents of similar causes and wait for unique problems. Thank you.